Hi everyone, I'm glad that you've joined me today. In this video, we're going to be looking at equations and determining if they are true or false. Now, I want to start out with a fun little graphic. Look at this graphic with me. We have Darnell here and he's saying, I am President of the United States. Well, Darnell might want to be President of the United States, but he's not. And so that would be a false statement. Well, we're going to be looking at number sentences and determining if those are true or false statements. So let's consider the statement 4 plus 5 equals 2 plus 7. Well, this is a grammatically correct sentence, but is the sentence true or false? Well, 4 plus 5 is 9, and 2 plus 7 is 9, so that is a true statement. Consider the statement 1 plus 3 equals 8 plus 6. Again, this is a grammatically correct sentence, but is it true or false? Well, 1 plus 3 is 4, and 8 plus 6 is 14. So this statement is a false statement. Now, the previous example statements are examples of number sentences. A number sentence is a statement of equality between two numerical expressions. A number sentence is said to be true if both numerical expressions are equal. Just like in that first one where we had 9 is equal to 9. If both numerical expressions don't equal the same number, we say the number sentence is false. That was like the second example where we ended up with 4 is equal to 14. That was a false statement. True and false statements are called truth values. So let's practice with a few. Determine whether the following number sentences are true or false, and let's justify your answer. Okay, well, remember if they're true, both sides are equal. Okay, so that's going to be our justification. Look at A. 13 plus 4 is 17. 7 plus 11 is 18. Well, 17 does not equal 18, does it? So this is a false statement. What about this one? Well, let's look at this one. First of all, I know that 1 4/10 minus 275 thousandths is going to give me 1 125 thousandths. So what I need to do is determine if this is equal to 1 125 thousandths. Okay, so let's go. 1/2 plus 5/8. I have to find a common denominator, don't I? So that would be 4/8 plus 5/8, which gives me 9/8, which is also equivalent to 1 1/8, and 1/8 is 125 thousandths, so this is equal to 1 125 thousandths. So yes, indeed, the two sides are equal, so this is a true numerical sentence, number sentence. Okay, so now what I'd like for you to do is to take a minute, pause the video, and try a couple of these on your own. Let's see how you did with those. Let's look at A. Okay, now in A, I'm not going to multiply all of this out. I can look and see that I have the same numbers. They're all being multiplied, and all they've done is taken the numbers on the left and they've moved them around using the commutative property, and they've regrouped them using the associative property. So I know that this number sentence is true. Okay, and my justification for that is commutative and associative, going to abbreviate there, property of multiplication. Okay, they just moved things around and regrouped, but they're still equivalent. Let's look at B. Now, you might look at these and you might think, these are equivalent because we've got that exponent property thing, right? But remember, that was the power of a product that said we could take the exponent and apply it to both things. Is this a product? No, this is a sum. Well, let's work it out and show why these are not equivalent. 6 plus 4 is 10. Okay, and 10 squared is 100. Now, 6 squared is what? 36. 4 squared is 16. 36 plus 16 is equal to 52. Those are not equal, and so this is a false statement. That's why there's no exponent property that says the power of a sum, okay? We have the power of a product where you can take that exponent and raise both factors to that exponent. No power of a sum. Okay, well, let's look at a few more things. A number sentence is an example of an algebraic equation. An algebraic equation is a statement of equality between two expressions. Now remember, a number sentence was numerical expressions, but an algebraic equation is going to be two expressions. Okay, algebraic equations can be number sentences when both expressions contain only numbers, but often, and most of the time when we see them, they contain variables whose values have not been determined. Those are typically the type of algebraic equations you're going to see, like this one. Consider the algebraic equation 4 times the sum of x and 2 is equal to 4x plus 8. Are the expressions on each side of the equal sign equivalent? Justify your answer. Well, yes, they are. Okay, and how are they equivalent? Okay, we can say by the distributive property. If we take the expression on the left and we distribute the 4, we get 4 times x, which is 4x, plus 4 times 2, which is 8. Both sides are equal, so this is the expression on each side of the equal sign are equivalent. Now, what does this tell you about the numbers that we can substitute for x? Well, if these two are equivalent, I can let x be any number I want it to be. Look at the left. What is that saying that I do to x? It's saying, okay, let's take a number, multiply by 4, add 8. Look at the right. What is it saying I'm doing to x? Take a number, multiply by x, add 8. So if I let x be 1, then I'm going to get 12. If I let x be 2, I would get 16. Okay, no matter what number I let x be, since the left side and the right side are exactly the same, it's going to end up being equal to each other. Okay, so what this tells us about the numbers we can substitute for x is that we can substitute any real number for x, and it will be a true number sentence. Okay? No matter what number that we put in for x, it's going to make it be a true number sentence because we are doing the same thing to x on the left that we are doing to it on the right. Okay? This is not always the case. And let's practice with some that are like that. Consider the algebraic equation. X plus 3 is equal to 9. Now, can I substitute any number in for x and make this a true statement? Absolutely not. What value can we substitute for x to make this a true number statement? The only value I can substitute for x is 6, right? 6 plus 3 is the only thing I can put in for x that is going to end up being equal to 9. So, how many values could we substitute for x and have a true number sentence? Only one, just 6. That's the only number. Number 4, consider the algebraic equation. X plus 6 is equal to x plus 9. What values could we substitute for x and make it a true number sentence? Okay, let's think about this. This says I'm taking a number and adding 6. Then this says I'm taking that same number and adding 9. Is that ever going to be a true number sentence? No, it's never going to be a true number sentence. Okay, if x is 1, 1 plus 6 is 7. 1 plus 9 is 10. Okay? There's no way I can take a number and add 6, and that's going to be equal to that same number plus 9. So what values can we substitute for x and make this a true number sentence? There are no values. So there are no values for x that would make a true number sentence. Okay, so we had 3 examples. In that first one, we saw that we could put any value because we had the same thing on the left as we did on the right. So we could put any value we wanted to in for x. It was still going to be true. In the second one, remember there was only one number. X plus 3 equals 9. So there was only one value we could substitute in for x. And in this case, there was no values. No way I can take a number and add 6. And that's equal to that same number plus 9. Okay, now that we've gone over those, I'd like for you to take a minute, pause the video, and try these 3 on your own. Okay, let's look at these together. D squared equals 4 is true for. Well, in this case, what number, when I square it, do I get 4? Well, first of all, 2, right? D could equal 2. But what about negative 2? Isn't negative 2 times negative 2 equal to positive 4? It sure is. So it is true for D equals 2 or D equals negative 2. Those are the only 2 values it's true for, though. Let's look at B. I have 2 times a number is equal to that number plus itself. This is true for, okay, well, what numbers could I substitute in for M and make that a true number sentence? Any number I wanted to, right? Because adding a number to itself is the same thing as multiplying that number times 2. So no matter what number I put in, it would be a true number sentence. So this is true for all real numbers, or any value that I wanted to substitute in for M. Now look at C. D plus 68 is equal to D plus 67 is equal to D plus 68 is true for. Was that true for any number? Is there any number that I can add 67 to and it's going to be equal to that same number plus 68? No, absolutely not. There's no number that's going to work for. So this one is true for no value of D. Okay, so I hope you had some fun looking at those and seeing where number sentences are true and when we have like one value that makes it true or infinitely many values that make it true or none that make it true. So now that we've worked on that, let's work together on a beat the test. Which of the following have the correct solution? Select all that apply. Okay, so in this first one, I have 2x plus 5 equals 19. Is this true for x is equal to 7? Well, let's see. I would substitute in 7 for x, so I would have 2 times 7 plus 5 equals 19. Well, 2 times 7 is 14, and 14 plus 5 equals 19, and that is indeed a true statement. So that would be the correct solution. Okay, let's look at the next one. 3 plus x plus 2 minus x is equal to 16, for x equals 3. So let's substitute 3 for x. I would have 3 plus 3 plus 2 minus 3. I'm just substituting in the 3 for my 2 x's is equal to 16. 3 plus 3 is 6, plus 2 is 8, minus 3 is 5. 5 does not equal 16, right? So we are not going to check that one. That is not the correct solution. Let's look at the next one. The sum of x and 2 divided by 5 is equal to 2, for x equals 8. Let's substitute in again. 8 plus 2 divided by 5, we want to know if that equals 2. 8 plus 2 is 10, And 10 divided by 5 is indeed 2. So we are going to check that one. 6 is equal to 2x minus 8 for x equals 7. So we're going to substitute in 7 for x. So we will have 6 is equal to 2 times 7 minus 8. 2 times 7 is 14, and 14 minus 8 is indeed 6. So we're going to check that one as well. So far, let me put a check by the ones that are true, and I'm going to X that one because that one was not. Okay, and the last one, 14 is equal to 1/3 x plus 5 for x is equal to 18. So let's look at that one. So we would have 14 is equal to 1/3 x plus 5 for x equals 18. So we're going to substitute 18 here. 14 is equal to 1/3 times 18 plus 5. 1/3 of 18 is 6. So that would give me 14 is equal to 6 plus 5. Well, 6 plus 5 is 11. That is not 14. Those are not equal, so I am not going to check that one. So the first one, the third one, and the fourth one have correct solutions. Okay, guys, thanks so much for joining me on looking at those equations and number sentences and determining truth values. Come back in the next video because we're going to start learning about solving equations, and we're going to use those properties that we learned back in the first section. So I sure hope that I'll see you around in that next video. In the meantime, you have a fantastic day.